This afternoon, we'll hear from HSA alumnus Josh Ogren, who graduated in the class of 2016. As a student, Josh distinguished himself as a critical thinker and assertive designer. His thesis project took on two challenges: mass tourism and the impact of sea level rise, focusing on Bajo Alto, Ecuador. Through a deep engagement with local culture, economic pressures, and technical strategies for resiliency, his design was a model of integration of the interdisciplinary approach taken by our curriculum, applying the methods and resources of a number of fields to his critical work as a designer. While a student, he studied in Barcelona, Spain, and he returned there to earn a graduate degree focusing on parametric design at ETSAV. When he came back to the US, he interned in St. Louis before joining Huft in Kansas City, where he holds the position of computational designer, and he works closely with architectural and interior designers as well as fabricators. His ability to work across these disciplines allows him to take an integrative approach to projects at a variety of scales and spanning diverse types, including education, hospitality, residential, and cultural buildings. He was a recipient of a 2023 HSA Alumni Design Award for Hobbs State Park trail shells in Rogers, Arkansas. His approach draws upon a deep respect for research as well as making. In addition to offering workshops on parametric design here at Drury in spring 2020 and fall 2022, in 2023, he co-led Ambitious Design Build Studios at University of Kansas, and it sounds like those are continuing. I want to encourage everyone to check them out. They are truly impressive and inspiring. I could go on, but you want to hear from him, not me. It's so great to have Josh back at HSA. Please join me in welcoming him.
Hello, I'm Josh, as Sandra mentioned. Thank you very much for having me today. I'm really, truly honored when I was asked to join you today and for the librarian event. And also, since I'm up here, just a very special thank you to all professors and faculty. I can honestly say you had a profound impact on me and countless others, as you can imagine. So as Sandra stated, currently I'm a computational designer at Huft and the fabrication company up in Kansas City, specializing in parametric design and digital fabrication. With the time we have today, we're really just barely scratching the surface of some of these tools and ideas and experiences I've had since I graduated. So this presentation will focus on my experiences since graduation, which has really allowed me to explore numerous paths within the architectural profession that I really didn't see when I began my journey. We only have a couple slides that are just quotes, but this one I'd love to start with. This motto is ingrained in our firm's practice. Just make it meaningful. Anything you choose to do is worth doing well and right, even down to the finest details. You can always insert meaning. We're also just storytellers as designers in a world where it's really becoming harder and harder to become original with thought or anything you make. The least we can do is just tell a story through the design. Brief history. The majority of this presentation, I've really tried to focus on 3 projects I'll show you towards the end. So this intro is kind of going quick up to where I've been at Huft and the fabrication company. I'm a huge believer that no one really 100% knows what they want to do. Our goals are constantly changing and evolving, and I kind of understood that at a younger age. So straight out of high school, I didn't know what I wanted to do, and I was content on waiting. So I just did community college for 2 years. Again, goals and interests were just kind of evolving at that point, and I felt like architecture was the path I wanted to go down. Always enjoyed art, physics, just briefly touching on that experience, just to focus on what we have later. Really with parametric design and the topic we're talking about today, that seed was planted in my head, I think my 4th year here at Drury. I took an elective class by Gerard Nadeau. It's a roller coaster of emotions just because it's hard to grasp the concepts and how to use these tools just in a small semester. But it really inspired me and, like I said, planted a seed. After graduation, fortunate to earn a job at H Architects, where I worked for 2.5 years. That really stemmed from knowing other alumni that had graduated, getting reference. So work across I know there's 5 years here, but it's very important to cross your years. It will pay off in the end. Over those 2.5 years, again, goals began to change. I started by the path of going for my license, passing 3 tests, but I really just didn't want that to be my path. I just wasn't feeling fulfilled with the traditional role in architecture. The firm was amazing. What I loved about it and was super useful and something for you guys to look for in your first jobs is finding firms that will actually be willing to teach you in detailing. Those 2.5 years, I don't think I would have learned as much from a lot of other firms. So that initial seed that was planted back at Drury about parametric design, I just decided to take a huge jump and go back to school to get the master's in parametric design in architecture at HSA in Barcelona, Spain. So I've said parametric design a lot. It's probably time to define it for everybody. It can be a tough concept to understand, but even without technology, I consider all of us parametric designers. All the decisions we make them based on constraints, whether it's one or a lot. For parametric design and technology, this is the last slide of just text, I promise. Parametric design, a computational approach using algorithms and adjustable parameters or variables to create complex adaptive forms, allowing for this rapid iterations and even searching for optimized design solutions. It's a big mouthful, but we're all visual learners, so the way I implement parametric design is through a program called Rhinoceros. It's a very robust and powerful 3D modeling program. Some of you may have heard of it. Within that environment, there's a plugin called Grasshopper. This is really where you write script, is what we call it, to generate geometry in Rhino. At a simpler idea, if you think about, many of us have played video games, you have a controller and a screen. Grasshopper is your controller, telling the screen what to show. So let's look at a spiral staircase. A very simple example of how to apply parametric design in these models. Defining what a spiral curve is pretty quickly, building steps off of that, and then off of that building a railing, getting geometry very quickly, and again, just as this shows you, very quick, rapid ability to test and manipulate geometry. So imagine that was on your Rhinoceros screen. If you have a second screen over here, this is what you see in Grasshopper. It's called visual programming. When we think of coding, typically that is lines of code written out that had absolutely zero interest to me. I never want to write code. Thankfully, again, visual learners, this tool was kind of groundbreaking idea when I found it. The way it works is inside each of these nodes is a very small script already written for you. So all you have to do is just play with your puzzle pieces, put them together, and explore your ideas. We're always working from left to right. And again, parametric design is heavily driven by constraints. Without constraints, you're going to lose your mind. You really need goals to direct you. We can think of that as the geometry. And then variables, really just data or numbers that drive what you want to explore. Kind of switching gears, just taking a look at nature. I love the word chaos. This chaos kind of comes to mind when you look at a lush jungle scene like this. Many people typically associate chaos with randomness, which a word I actually really don't like, because nothing truly is random in the world. You've heard the saying, there's a reason for everything. Everything has its own purpose and DNA of its like appearance. Even at a smaller scale, if we just compare two leaves of lettuce, two different types, and without going into like scientific background, we can just use our eyes and just visually analyze, and then take those concepts and use parametric design to replicate. So on your left, you have romaine lettuce compared to kale on the right. Very different textures without even holding them. One looks crunchy and the other one looks flat, floppy. Leaves are a natural thing. We know they grow bigger over their lifespan. So associating some kind of geometric relationship and why the growth of these results in their shapes. As I said, everything grows over time. If the leaf gets bigger itself, that's one thing, but how the edge grows with that is what we could say determines one way to get to these shapes. So romaine is constantly growing together, whereas kale, the edge grows at a slower rate than the surface. Again, taking those concepts into parametric design, very fluid, very quick way to control variables. Adjusting that relationship I just explained. I will briefly touch now on the parametric degree in Barcelona. Again, just scratching the surface. This was, again, an emotional roller coaster of learning this tool. It can be very complex in learning geometric principles and getting back into math. It almost felt like one week you kind of understand things, making progress, and then the next week you crash and you're like, why don't I understand? But just hanging in there and working through it, good things happen. I will say too, in today's world, I think it's very obvious that technology is rapidly advancing, and I think that is a huge opportunity for any of us to specialize in something and set yourself apart from your peers, especially when searching for the job you want or a position you may want to create. In this degree, just like Drury, we started out outside of the computer. Really just how can we conceptualize and understand pattern making and what that results, how that can result in unique forms. This was a topology workshop. Our goal was to recreate triply periodic surfaces without super explaining that. These surfaces have a pattern that can repeat and grow infinitely in all directions. We were given literally thousands of these laser cut rectangles. One side was painted blue because it can get very confusing as you start to implement curvature. But again, the patterns we were really studying were different shape-sided polygons and how they affect the curvature of this three-dimensional shape that kept growing. The one you're looking at here, again, looks like chaos, but there's a very high finite or high small level of order allowing it to look like that. This one was only created with six-sided polygons and seven-sided hexagons and septagons. The last kind of project I'll touch on through that degree, I think this shows us one, not only the ability to make the geometry, but how to use that and extract the data to make it even better. This form is called a parabolic cyclide, and our task was to generate a structure on this surface. By saying structure, really just think of a network of lines. It was an extremely difficult surface because it is, at any point on it, it is constant double curvature. As we were exploring options, came up with kind of three patterns or three structures on these. And also, just like any scientific experiment, and for comparison of these to be accurate, they were all made with triangles, and they were all made with roughly 3,200 panels. This is the data analysis you can get out of Grasshopper very quickly. Not only, like I said, is it making the geometry, but it's how do you actually think about fabricating it and bringing it into the real world. Again, three different structures, comparison of each. There's three different columns here. The first one is comparing beam lengths. How much do beam lengths differentiate from each other? If you think about fabricating something very complex and unique, and you have 1,000 parts that are all different lengths, different shapes, holes in different places, that can become very confusing to fabricate. So simplifying even your structures ahead of time will save you in the long run. All right, back to the timeline. Done with school, got to figure out what I'm doing next. I was fortunate to, my professors in Barcelona hired me. The degree was 9 months. I had like 3 months left on the visa, and I was not coming home early. My professors, I was fortunate enough, they hired me to work with them, and then I had to jump ship and came back home. I was very fortunate to find a firm called Huft in Kansas City. I'd kind of heard of them before, but didn't really know what they were about. But when I went to interview and looked them up, I realized how unique they were, and the fact that they have a fabrication shop within the firm. It's pretty rare to see. What that means is architects, interior designers can constantly work and get better knowledge directly from someone that has the knowledge of materiality or putting specialty things together. When I got hired, I was pretty fortunate to just kind of create my own position. Again, architectural projects take so long. I did not want to be on that path and be stuck to one thing for years at a time, potentially. So I really get to float around and poke at the more or less cool things of each project and then make them. Recently, we actually separated the two, so the fabrication side doesn't have to just be behind this kind of shadow of Huft's projects only. We're beginning to collaborate with other architects and general contractors to bring in other designs that others can't figure out. Quick look at our team. Very collaborative space and very interdisciplinary. Not only do we have architects, there's probably about half architects, half interior designers, and then supporting roles we have videographers and graphic designers. You can see in the office tons of prototypes, very industrial space. Even we do pinup still. It's really trying to keep that educational vibe you guys go through with critiques and actually working with real tangible things. Shop side, just going through that again, interdisciplinary casts of characters back there. We have a CNC operator, a full-time job, 8 hours a day. We've got the CNC running, cutting out custom parts for cabinetry, furniture, and then specialty objects. We have a few wood craftsmen and craftswomen. We also have people with backgrounds in model making, sculpting, painting, and a couple of them actually worked at museums before, helping curate and change out displays. As you can see here, they're doing packaging and handling. That's part of when we make something, we also have to deliver it and install correctly. This is the metal shop. Super fortunate to have, we just have one, I call him a blacksmith, not really the true term anymore, but fortunate to have him back there for all custom welding and cutting. Even a large paint booth, everything we make, we want to finish in-house instead of sending everything out of house. And then again, model room, we at our firm, we do not shy away from still making models and prototyping along the process. I think we're doing good on time. This is just a quick range of projects we do before we dive into some parametrically and computationally driven ones. Our scale of projects is massive, from institutional buildings like the one you see to renovations or additions, especially historic preservation sometimes. And then interior design is a really big portion. Building a new building is not cheap, so not a ton of people always do it, nor do they always fulfill their project life of being built. This is 21C in St. Louis. That sphere we did not do. That was another artist, but you can see the leather screen on the left of these twisting braids. That was the only thing I helped out with this project, but again, like, wonderful to be able to go in and out and just help where needed. Corporate office spaces, we do a ton of them. It's very hard sometimes, again, to be original, and choose your battles of where you can make the most impact. This was a law firm. Paper is always a thing, and they always bend their corner to remember where they're at in their set of documents. But anyways, taking a typical ACT system grid, but filling it with custom shapes, just dynamically change the space. At an even smaller scale, we were not architects for this project. We were asked to do this feature wall. This was a 20 by 35 foot feature wall. 652 individually placed parts on this wall. We fabricated each of them. It almost felt like a baseball bat factory at one point. What you see also are 3 shapes that repeat in a pattern that appears random. Even smaller scale wall paneling with the CNC has so much ability, not just cutting out shapes, but adding textures and patterns. Also furniture, like I mentioned before, that might be one of the biggest tables we've done. It was a 36-foot long bridge, essentially, that we coordinated and had structural engineer provide a steel I-beam that's hidden within. And then even smaller, just art pieces. We were commissioned to just kind of fill a wall. This was in a building called Reverb, dealing with sound. So we took that concept, and this piece was called Sounds of Earth. So recording sound, translating it into a 3-dimensional piece. So I'm going to dive into some really fun projects now. This one is called Embrace. I know we're in an architecture school, but this to me is still architecture and the experience of space, let alone understanding how to just conceptualize and then fabricate something in the real world that can be simple or complex. Our client was down in Bentonville, Arkansas. We were already doing a renovation on their house, but the client has this long winding driveway, very steep hill, but just beautiful forest as you approach the main area by the house. But the client really wanted a pavilion that served as a welcoming point into their site. These were, Sandra mentioned, we did these trailheads a few years ago. Our client came to us and said, literally, I want that. We're never going to repeat anything, so we had to take inspiration from our own projects and how can we progress what we previously did. This was 2x2 stacked steel tubes made into a spherical form. The other thing the client said that we kind of grabbed and caught on to as a concept was he wanted to feel like he was being hugged. Kind of a weird request for a structure to do that to you, but it was a nice challenge, hence the name Embrace. So it was a perfect opportunity to implement parametric design, especially when studying the form. These are the steps of our final geometry. There was probably hundreds of studies before this as we fine-tuned what felt right. But again, embrace, this being the idea of a hug. There's two arms to this structure, kind of opening up and welcoming you in as you approach. We also changed the height to where it incrementally rises from 4 feet at your entrance all the way up to 16 feet, as well as all these, the form would lean inwards to an overhang of 5 foot once you got all the way into the space. Again, similar in vein to the previous Hobbs project with the stacked steel tubes, we decided to really challenge ourselves and use steel pipe round tube in this application. And so you can imagine trying to just stand pipe up and connect it in weird ways is just naturally a problem in itself. Each arm is actually 2 rows of pipes that are leaning inward, and then their pattern is alternating, so you get this diamond-like pattern. Computationally, the most important step was finding the connection points for these 2 rows of pipes on each arm, what I call the brace vectors. Vectors are just a direction in space. So when we think about that, again, tubes, much harder to deal with than square tube, but our process of fabricating this was another vendor in Kansas City has a machine that we can literally just send a 3D file to. The machine will pull the tube into it, laser cut and etch labels and holes as programmed while it's rotating the pipe at the same time. When we're making these brace connections, I think it's pretty obvious and a logical understanding that the one on the left is what you need to shoot for. The way the machine works anyways, the one on the right it's just not possible. The machine's always cutting at a perfect 90-degree angle to these tubes. So what that means is now we have to kind of search and do some math to find where these connection points actually land once we've decided the form we want to have. So as I said, there's 2 rows of pipes. Each of them actually create what's called a ruled surface. It's a surface generated from the curves, not the other way around. Because these 2 rows are angling different ways, naturally their surface is slightly curving at a different vector. But searching for that very small connection point that is the most 90-degree angle for both of them was crucial. So here is me projecting one point off of the inner surface, and you can see when it hits the other surface and it takes its perpendicular, they are not the same. We realize that's a constraint, but we know we need to build tolerance into our cuts, but we can also use parametric design to minimize this gap. Pretty colors, that's another fun thing about it, analyzing the data. So taking multiple points between multiple sets of pipes. This is a better image, zooming in. Red is the closest vector to 90 degrees, and as they move away between each pair, it's pretty obvious that it's not 90. Very simply, turning lines into 3-dimensional geometry that we can start understanding how to take to fabrication. Through all that, the script setup, we understand how the braces work. We can really play more and explore what our design option wants to be, essentially how much of a pattern we're creating. A really beautiful result out of this. I wish I could say it was intentional, but because we have these 2 rows and they're kind of weaving, the way they connect, each wall is actually 2 walls within itself, weaving. What that also means is now the full weight of this structured leaning is now split in half between 2 different sets. I don't like to show scripts a lot, but since we're doing this today, I think it's important. Might look like chaos, but again, high level of order going on. Any decision you make will change everything, not just from your initial geometry, but to the output files that we're planning to send to the fabricator. Just quick rendering. So I love getting to this stage of projects. What you see here is on the top, all of the parts. Give you just quantities of each, the small arm and then the large arm, and then all of their connecting braces. What you see on the bottom is writing a script to optimize how these nest into the pipes we are purchasing. You can't buy an unlimited length of pipe. We had to buy them all in 20-foot lengths and ship them to our vendor to cut. But they, again, were telling them which geometry to cut and which order, so we could effectively minimize a ton of waste by doing this practice. So I get to wear many hats. It's really, really lovely to kind of not only be the architect on a project, but then follow it through in its construction, essentially a design build kind of idea. We had no civil engineer, so a SketchUp site is what you're looking at, and we, just by being there and experiencing it, we understood there's quite a slope to the site and the way this wants to sit, really meaning we had to add a retaining wall, work with a structural engineer, one to make sure the sculpture would support itself, but also not collapse under the weight of what we're designing below. What you see on the bottom left are the very quick output of the base plates that we needed to coordinate with the builder. They needed to be integrated with the foundation and set level for this to work. We built in tolerance on the pipes, but the most control we can have, the better. Just a quick look, our estimate from our site topography was a 5-foot max exposed retaining wall at the far end. Just a quick look, I know exploring, seeing the sculpture side and geometric evolution is fun, but it's always going to come back to how it's built, doing the detailing. And then prototyping, we're very fortunate to be able to do this in-house with the staff we have and tools and equipment. That's our welder there, kind of starting to cut pipe. Here was early prototypes, and again, these are moving along at the same pace we're developing our script. Just early connection studies of the braces. We needed to build a mock-up. There's no way we're going to go try and do this thing one shot. We need to build a mock-up, make sure we're not extremely crazy, and it'll work. What you see here is, again, using our CNC router to really build this guillotine-looking shape. This cradle is what we called it, to establish the first module of the structure that then we can continue building off of. Bringing the client in, mock-ups are just so invaluable from my experience. You getting out of the computer and doing this, you just learn so much every stage of the project. Also going to site and understanding scale in the real world, like rent on site. The client was okay with that direction. He actually had a crew on his property already that had welding equipment, so our welder and I went down for site support and worked with them, and we just kept adding pipes. Again, just continually welding. Completing the small arm, we had scheduled out 2 weeks for this to be built. We actually did it in 2 phases. One was January. One was in November, the other one was in early February. Fortunate to not get cold days on either one, but we had forecasted 2 weeks, not really knowing how long this would take, but we completed this in 3.5 days. On the ground, you can see the brace vectors. Those are all labeled as well. They may look identical, but they incrementally grow as the structure is leaning and twisting. So each one has this very specific spot to be in. Just kind of final picture, start to get these beautiful shadows on the ground. We also designed that fireplace you're seeing. We were planning on fabricating it in 3 sections. And then we found a fabricator near our client who had no problem building it out of one large single sheet of steel. Looks a lot better that way. That was the crew. I actually got my eyes sunburnt the second day. That was excruciating, but we made it. Slowly getting landscape, and this is a recent video brought to you by Dolby Vision. Tried to keep the site simple, but all this finished grade ended up hiding the base plates and having the retaining wall on your right just kind of coming up level just above those. We designed and fabricated the benches as well. They'll be benches were intended to kind of hold all the firewood. And then that fireplace, they have some really big fires, some good Boy Scouts down there. Our second project is done with, as Sandra mentioned, we've taught at a couple design build studios at the University of Kansas. Very rewarding experience. I really love getting into that environment and just seeing the growth of students over a semester. I'm sure you guys can see it in yourselves over time. So this project, this was our second stint. I'll kind of skip a lot of the work. First half of the semester, we kind of just work outside the computer, understanding how we can make patterns with small shapes, as I showed you earlier. And then we kind of get them into the shop. Some of them, it's the first time they really touched a saw, used a hammer, so really getting their feet wet. And then I kind of forced them to do a parametric workshop for a week in the beginning. Some of them grab hold of it, but regardless, enough of them do that we implement that through the rest of the semester. So this project, what we'll show is only 3 months of work. It was a 9 credit hour class, and I for sure made them earn those hours. Actually, sorry. So beginning of this final project, we had a sponsor through Huft, which was a client. So the students were actually able to talk to a client, get this real world experience, hearing like what they envision and what they're asking for. They were asking for a sculpture that was going to go in their lobby. Their firm was called Five Elms Capital. They're in Kansas City. The name Five Elms was a pretty easy grab that students ran with. Always putting up a mood board or inspiration before we show clients something is a smart thing to do. It kind of helps you understand where their mind is and where they're going. So fine-tuning that. Really starting to think of this leafy, airy, hanging sculpture that we may go after. Quick look at their floor plan. It's a renovated space on the 7th floor. Anyone who comes up here will enter through the elevator lobby to the south and immediately experience the sculpture as you enter reception. Tons of design iterations over the short period of time, but this is what ended up as the final thing. Their job, again, the client was sponsoring them, so they expect to receive this sculpture. You can see it's, the idea was 5 elm trees, just really conceptualized in a 3D fashion. It became a suspended system, if you will. Really imagine this box that you just pulled open and find this nice sculpture. It was created out of 5,000 leaves. So with parametric design, we can easily control data and quantities of what we're making. All these leaves were strung on steel cable, and what ended up being 748 total cables, but the total length was 1.09 miles. So we went through a lot. The leaves also varied from shades of wood, dark, medium to light, and then aluminum. So being able to laser cut out aluminum, understand the brushing versus polishing, finishing sequence of them. Sketching, again, it's design build, so things change, you just got to deal with it, roll, make the best of it, always sketching out ideas. Quick look at the architectural documents, if you will, that students produce to get to the final fabrication. The sculpture consists of 9 boxes, all with these strings going between top and bottom. It's a 9x6 area and plan, and it was 10 feet tall. A lot of effort went into figuring out and simplifying the details of the ends of each cable and really how to hide them in a clean and cohesive way. Also, needing to be able to tighten these wires is something we found. You can see turnbuckles at the bottom base. This was the student's script, not mine. It was really rewarding to see how far they could get in a semester. And again, on the left, not only defining original geometry, but on the right, having output data to guide everyone on how long the cables were, and then where exactly each specific leaf went, whether it was a wood leaf or a metal leaf or a shade of color or polished or brushed. They really became their own firm for 3 months. Everybody had a role, and everybody needed to communicate, collaborate with each other. The client's renovation was not going to be finished by end of the semester, unfortunately, but they were still willing to sponsor, and what that means is the students also then had to add in a fact of breaking this down and storing it at the end for us to install as easily as possible later without students. But they still have to make it themselves, so created their own ceiling system for us to mount to. Here's a look at really prototyping like density of leaves, size of leaves. This isn't steel cable, it's just string. You don't always need to work with the final material if you have something cheaper that represents the ideas. Again, this was lots of their first time milling and working with lumber. Not just even a CNC machine that cuts for you, but other manual tools. You can see eye hooks in the bottom that then would then be enclosed and have the steel cable running through. This was just a prototype, but just proving the system. Again, checking in with the client, one final check-in before they don't sleep for a week and finish this project out. Just a couple process photos going through the whole system. Everything was guided by the parametric script, and they would print out, I'll have it in a couple slides, but you'll see some of the printouts that really guided it. But again, quantity of things, a couple students, their role was to cut out leaves and then stain them as well. It's not just as simple as cutting them out, you need to finish them. This is a finished sculpture. We can't have frayed edges on these wood pieces. Here's an example. It was kind of hard for me to go back and kind of get the files that I was looking for, but I found a photo at least. This is one example of one of the boxes and all of this, some of the strings that go, some of the cables that go in it, and they would lay them out on the ground and then attach with a tape measure next to it and attach the correct leaf in the correct dimension. So it was time to kind of start stringing it up. It was really beautiful to see it evolve from the first box to the last. You just really started to see it take its shape, and finally, not a rendering. So that was end of semester, how they presented it. Again, client was currently being renovated at that time, so they had to break it down and store it. We'll see that result in a second. Just some details. Again, something that may look chaotic, that has a very high level of order to it and intention. I think it was about 6 months after this semester was over. Before semester was over, they actually took the tops and bottoms and broke them, kind of brought them down into a box. They used them as part of the crating system. They just kind of put plywood walls on the outside. And you can see us in the space putting up the first box. When I'd gone to site, kind of a funny story is we had them build out this ceiling, and they knew that a sculpture was going there, and we were suspending something very heavy from it. I'd asked the GC if he had done 2 layers. You need a couple layers of plywood to help secure into it. He's like, oh yeah, no problem, we did it already. I'm so glad we drilled a hole in that ceiling before we started and checked, because they didn't put any in there. That would have been a disaster if we didn't check. When students broke it down, they had to individually roll these up so they wouldn't get tangled. That was a little painful to re-roll back down, but again, no tangling, just patience and time. And then the final product in the space. Pretty rewarding. Students also collaborated with our architects on the lighting, really giving these beautiful shadows, especially on cloudier or later in the day, cloudier days or later in the day. Here's our students. We have time for one more. I'm doing all right on time. Last one. We actually completed this sculpture less than a month ago. This was called Harmony in Dichotomy. This was a collaboration with another artist. This sculpture is in the Kansas City Zoo aquarium now. You can go experience it. The artist, Bryn Montre, she had won a design competition for a sculpture to go in this space, and this was what she had. Beautiful design. It's this swirl of fish, kind of very dense, and each fish was actually modeled and shown as a volume. This just hurt my heart and brain so much when I saw it, because that's just not buildable, and that's why they came to us to redesign and make it buildable. So understanding the vein or the target we need to hit and the vein and concepts to keep, we kind of started back from square one. Going to site, understanding the extremely difficult space we had to work with. It was a very tall atrium space at the end of the aquarium path. There's otters kind of right next to us. Became good friends with them for the week of install. But the ceiling is this triangular shape that is just sloping at a very steep angle, just already in your head, causing you to think about how to approach a sculpture in this. Her concept, actually in the aquarium, there's this pool of fish that swims in a circle naturally. They're called the yellowtail fusilier. So as you go through the aquarium, you can see this and then get to the sculpture and ideally make a connection. Our first step, without even redesign, like starting in the computer, was what in the world are we even hanging? We knew we weren't going to make a volumetric object. We needed to simplify it, one for cost reasons and just complexity of making something like that. This was the shape that we cut out of 100% recycled plastic and used a blue dye to kind of color match what the artist was showing. We took those, and to kind of represent that three-dimensional and curve-like form the artist had, really milling out a form that we could heat these plastic fish to, and it's kind of quite an ambitious idea, but it did end up working. One of our vendors, we were just kind of taking a tour. They're a printing facility. We were taking a tour through their shop, and we were like, "What's that piece of equipment?" And they said it's a large industrial oven that they just don't really use anymore. And so once we got this project, it kind of like that idea came back to us, like, well, I guess we could use that. And we made it work. So putting the fish on top of this mold, sticking it into the oven for a couple minutes, letting it get soft. When you pull it out of the oven, just kind of pressing the top portion of the mold onto it to kind of get your clean shape. Now that we know what we want to hang, we got to figure out how we want to hang them or get them in the space. First idea was, it was super fun to think about. And if you think about a spiral staircase, or really what's shown here is this double helix. And even in the vein of like thinking about roller coasters, you can fabricate curved rail. It is custom, but it's doable, that we could then try to hang things off of. Mocking up and prototyping, huge portion of what we do. Then really taking that idea to the next level of, can we use the shape of this truss essentially to help spread out the fish, kind of solving our problems before we get to them a little bit. So we looked at a triangular truss shape that would then try to spiral down in about, I think it was 35 feet tall. So here's a script of that. Again, real easy to use use your base spiral curve, generate this truss structure off of it. Variables you can constantly change, and then dropping fish off of that. This was pretty early as we got real excited and exploring ideas. Eventually, we had to talk to the structural engineer that built the aquarium, and that quickly kicked our idea out of this roller coaster kind of rail. The structural capacity of the ceiling needed to be spread out a lot more than just focused a couple of points. Regardless, taking away the truss, the concept of those 3 hanging points to help us separate fish was critical. So really looking at now, instead of hanging them off of something that's being hung, we have to hang each fish individually up to this incredibly difficult slope ceiling. I'll play this animation again, but power of parametric design. Those green dots on the top, that's us analyzing proximity and closeness of fish. We knew we couldn't make 1,000 fish, and budget-wise, we targeted roughly 350. So playing with our variables, adjusting that, knowing proximity for these not to get tangled was pretty critical. At the same time, unrolling those points on the ceiling onto the ground in a flat plane at the same time was critical to see and analyze. Our idea was to kind of print plots of paper and plot them up on the ceiling to guide us where everything needed to be specifically located. Back to prototyping. Again, getting out of the computer, you can only do so much in there. How is this thing actually going to work? What are the mechanics or I guess hooks for it? It's pretty easy for us to go down the line of fishing equipment. So we studied numerous fishing lines. One, not only for transparency, we wanted it to disappear, but also for how well their elasticity properties were. We really didn't want something that could kink easily if we're going to hang something so tall. On the left also are just various different hook studies. They're very small, and you can imagine doing a lot of these with a single hand. We needed to find a hook that was not going to drive us crazy. The ceiling anchors you see on the right, we ended up painting them white. Again, everything we wanted to disappear as much as possible except for the fish. All the data for hanging the fish was directly output of Grasshopper. It was very quick. Just take it, put it in Excel, print it out for our fabricators to then do these custom lengths of string. What held the string onto the fish were very small ferrules. This actually became just kind of a beautiful drawing in itself, the plotted constellation of points, if you will, on the slope ceiling. Again, this shows the plotted papers, or the papers we were going to plot out and then put on the ceiling to guide us. So here's the data I was talking about. This took me a minute to output and get started for our fabricators on making each fish. The fish were hanging at an angle, and they're hanging off an angled ceiling. So the length of each fish also had two strings. So the length of each constantly changed depending on how it's swimming in this spiral at a downward angle off of a sloped ceiling. So some process pictures. Before we even wanted to think about the slope ceiling, we wanted to do this on a flat ceiling, make sure things were working. Very nice to be able to do this in-house. We also were fortunate enough to do a mock-up on-site. This was extremely critical. This took us, I think, just a day and a half to do. But what happened is they got tangled. As you can imagine, it was a pretty obvious duh moment for us, but we didn't realize that the adjacent doors were actually being opened all the time. So one day it was an extreme amount of wind, and you can imagine all just the pressure in this very tall atrium just began to just move. So we had another problem to solve, no problem. But just thinking about it, it really kind of led us into thinking about like a net, or if you think about a mobile. Even from this net example, if you lay 3 nets within each other and kind of fold them up, they won't tangle. They'll still kind of work together, but in layers. The solution was not parametric or technology driven at all. It was pretty obvious what we needed to do. Started connecting these. We have the laser cutter in-house. Laser cut these rods that were at various lengths from 3, 4, 5, 6, 7, and 8 inches. So as we were going to be building this, we could just have a whole set of these lengths and then put them where they needed to go. Sorry for the sound. Just testing it, making sure more or less we're on the right path. We were pretty confident with it. Even having the client back out to do that was very collaborative. So onto the final drawings. We had 3 different sizes of fish. You can see them separated out here. The final number was, what was that, 331? The space was super constrained. You can see the rocks, fake rocks on the ground to the right. What that means is that we couldn't really use the full ceiling you see above because the lift we needed to use couldn't access certain points. So even before getting there, understanding and visualizing your process of installation was crucial. Just a couple sections and enlarged views of the drawing. You can see on the right all those pieces of paper where they would go exactly, labeled. More sheets of data. Very helpful for kind of packing things correctly. Given the sloped ceiling, we had to work from low to high with our back kind of working away from it, or working backwards. We couldn't really lock yourself into a corner. So as all these fish are swimming in a circle and numbered accordingly to that spiral, the way they were installed was not a consecutive number. So being able to sort that data again to be able to box it up correctly and help us on site was super helpful. Just a couple shots of that, getting ready to go to site. It was pretty fun. I got to drive my car through the zoo for a week. And here's final install. All the papers you can see were plotted up there. I keep saying plotted up there. They were plotted, then taped up there. Quick image of that, and then we have a time lapse of this. We got some cool. Again, very helpful to have a videographer, graphic designer on our team. I hate doing this stuff, so it's very nice of them to help us out. It took us a whole week to install, just 2 of us on a lift doing it. Ray Copesel was the other one. She was a huge help to this. She did a lot of the work once the data was out of the computer. She kind of did a lot of the organizing and work. Up and down for about 4.5 days. And then the kind of final thing. We were pretty happy with the way it turned out. It's not exactly what the artist rendered, but it's something reasonable that could have been built. Just a final look at it. 331 fish. Again, total length of fishing line we used was over one mile. Those little connectors you saw, we actually used earring backers to hold them up in the right place. They grabbed the wire perfectly. We used probably over 600 of those. I think that's all I got for you. Just make it meaningful. Just have fun. Thank you.